So we'll get started first with deploying Clowder session. This will be, the presentation will be by Rob Kooper, leads research software engineer at NCSA. The floor is all yours. Thank you.
So I'm Rob Cooper. I'm going to be talking to you about deploying Clowder. What I'll start with is some of the dependencies that people have talked about, how we have deployed Clowder in the past and still do it in some other locations, moving towards Docker, Kubernetes, and then I think the most important thing at the end is the ability for you to try things yourself and to hopefully make it easier for you to test things without getting too much in the weeds. So we have some dependencies in Clowder. The one main dependency is MongoDB. That is a required. It has to be version 3.x. It cannot be the newest version 4. Other optional dependencies that most people will deploy is RabbitMQ and Elasticsearch. Additionally, we can depend on GeoServer, and then there is many dependencies on the extractors. The core extractors, there's audio, video, PDFs, etc. Zip extractors, we have an antivirus extractor that will check every file that you upload to make sure there's no viruses in there. If you have the GeoServer, you probably want to deploy the geo extractors as well. And so what we go through, when we set this up in a native deployment, everything runs as a Unix service. This is an advantage because a lot of these sysadmins are familiar with this. They are familiar with how to run things as services, system control up, down, etc. Clowder is not a native package you can install, but we have a very simple install upgrade script that you can run. We have in the past deployed this using Puppet. So we could just install everything using Puppet, and it was very easy to set up. Another advantage is we could share infrastructure, and I'll show that in a second in the next slide. And the only thing that Luigi already pointed out is we have this /custom folder, which holds all the configuration values, and all you need to do is back those up before you upgrade. All the customizations for that particular Clowder instance will be stored there. The disadvantages are it's complex. It's a very complex system to maintain, and it's hard to upgrade single pieces. And what we ran into recently was an unexpected OS upgrade problems. For instance, we upgraded our systems from Ubuntu 16 to Ubuntu 18, and that resulted in Java being upgraded from 1.8 to 11. And Luigi already pointed out is that Clowder right now is not compatible with Java 11. And so we had to figure out how to downgrade all the machines to Java 1.8. How does this look like? So what we have is deployed on some of our systems here, and some external systems as well, is we have a cluster of Elasticsearch and a cluster of MongoDB. This way we have security in the sense that we can lose one of those machines and not worry about it too much. We have Clowder, we have RabbitMQ, a lot of extractors sitting there, and Nginx. Each of these boxes is a virtual machine. And so as you can see, this is a very complex architecture with lots of virtual machines. And if we need to do an upgrade like we had to do recently, like I said, it's a lot of work to upgrade all these machines to the latest version of the OS. And if you think about it, Python 2.7 is no longer supported. And so all those extractors that are dependent on Python, it's a really difficult process to upgrade all those extractors from Python 2.7 to Python 3. So what we want to do is we want to simplify this. Obvious solution that most people are familiar with are containers. So it's a standard unit of software. Everything is packaged inside this single container. It's all the dependencies, all the libraries, everything you need is inside this one unit of software. If you think about it, we now have a container that has Java 1.8. Even if we upgrade the underlying OS, the container itself will still have Java 1.8 in there. So the Clowder binaries will no longer have the dependency on the system version of the Java that gets installed. We just have the version of Java that is installed inside the container. And the containers, really what you should think about the shipping containers. These are very standard. Everybody can run them. Most people will use Docker for them, and that's what we use most of the time here as well. But there's very many other container software, such as Containerd, Podman is another one, and many other ones. And all of these work because they're based on top of this Open Container Initiative. So what we end up with is a Docker architecture that probably looks very familiar to what we had before, where we have Elasticsearch, Mongo, RabbitMQ, extractors. But in this case, each of the boxes is not actually a virtual machine, but is a container, and it could run on any machine that runs Docker. And so this makes it a lot easier to upgrade, because now what we can do is, if we want to say upgrade one of the extractors, we just simply have to stop that container, replace it with the newer version of the extractor, and start that extractor again. And we don't have to worry about which version of the underlying Python we are running. We just move everything over from one container to the other container. Classic XKCD comic that basically explains this process. What we do is we basically grab lots of these containers, some of the standard RabbitMQ, Mongo, Elasticsearch, traffic, and basically glue them together. And what we end up with is this wonderful system that basically is a lot easier to maintain than the native system that we had before. We no longer have to worry about what happens if we update Mongo? Does it pull in any other dependencies that we don't need for Clowder, or does it break Clowder? We basically have this completely separated pieces of software that we just glue together. Now, the big question is, how can we glue this together? And this is where Docker Compose comes in. So Docker Compose is used to glue things together. It is a very simple orchestration of containers. We have a single command to start and stop a full Clowder stack. The standard Docker Compose file that we have with Clowder, it sits in the GitHub repository, will make sure that we start up Clowder, MongoDB, RabbitMQ, Elasticsearch, and traffic. With this, you have the core pieces of the Docker architecture up and running. You can use this to, within almost no time, have a complete stack of Clowder up and running on your Docker machine. This is also a great example of how to do local development for extractors. You can use this Docker Compose file, bring up a full Clowder stack on your local machine, build the extractor on your local machine, test everything, and when you say, I'm ready now to have it go out into the official supported Clowder stack by my institute, you basically say, hey, the extractor is ready, here's the Docker container, and then the admin for the Clowder stack can deploy that specific version of the extractor. So this makes it a lot easier for people to develop locally on their machine than having to install all these native pieces or figure out how to put all these containers together. Now, one thing we can do is we can customize the specific version of Docker Compose. And what we recommend doing is there is a Docker Compose override with a YAML as well as a .env file to configure these. So leave the Docker Compose.yaml file that you download from Clowder as much as possible the same, and update that as we have newer versions. That way you get any updates and improvements that we've made to the Docker Compose file. What you do is you actually edit the .env file to change some variables. So for instance, if you want to change the traffic port from the default port 8000 and change it to a different port, all you need to do is change the variable traffic HTTP port in your .env file. Do Docker Compose up, and it will immediately take effect. The same thing you can do with the Docker Compose override.yaml file. This way you can extend the existing Docker Compose file and add new extractors or change certain services. So for example, there's an example of a Docker Compose override. We change the service by adding an extra previewer, the image previewer, and that's all you need to do is basically add that section for the previewer. This will basically start the previewer whenever you bring up, do Docker Compose up. What it will do is it says it will wait for RabbitMQ and Clowder to be up and running, and then say, start the image previewer. It will also use the RabbitMQ URI variable. So if you have changed the username password for RabbitMQ, it will use that. Finally, the other thing that we do in this particular Docker Compose override is we make the port for RabbitMQ, the administrative port, open to the public. So if you then connect to 15672, you will actually see the RabbitMQ management interface and be able to interact with RabbitMQ directly. I would not recommend doing this on your public instance, because this will allow the internet to access your RabbitMQ management interface, and especially if you leave it as guest, people will guess that, actually have access to your RabbitMQ interface and be able to see all the traffic that goes through there. But for development, this is a really convenient way for you to look at it and see what messages are there and check to see if all the messages are going into the right queues. Finally, once we have done a Docker Compose up and we do Docker Compose PS, we can see all the pieces running. So in this particular case, if you look, you can see on this machine, I have Clowder running, I have a digest running, I have an Elasticsearch running, I have Mongo, I have RabbitMQ, and I have traffic running. This is a complete traffic, this is a complete stack of Clowder. As you could see, at this particular point, I have all the ports that I need to open. I have extra ports opened up for debugging. You can see that port 9001 maps to port 9000 for Clowder. I have the Elasticsearch ports open, so I can look at the Elasticsearch. I have the MongoDB open, so I can debug MongoDB, etc. This allows me to do all the debugging I need to do on my local machine, see Mongo, see Clowder, see any of the Elasticsearch, and make sure that everything is working as I need it to. Once we have the extractor running, I can add an extra extractor that runs here, connects to the RabbitMQ on localhost, and sees all the messages come in. This is a great way for building an extractor without having to install any of the other pieces that I need for Clowder. So Docker Compose has the pros of easy to manage, easy to install, and easy to upgrade. Really, I don't have to install much. I can just download the Docker Compose YAML file, run Docker Compose, and I'm up and running. If I want to, I can do a Docker Compose pull to get the latest version of all the images and be able to look at those images, do a Docker Compose up, and get the latest version of Clowder running. Now, the disadvantage is that Docker Compose, unless you use Docker Swarm, only works with a single Docker machine, which means that if that machine goes down, our Clowder stack is down. So we have a single point of failure. This is not what we want to do. It is not very easy to scale containers. If you use Docker Swarm, it's a little easier, but otherwise you will need to add a second instance of the extractor to it to basically scale up the number of containers. There are some difficulties with configuring Clowder. We have the configuration file sitting in a special volume. Some people might have realized that when we went through and removed the plugin for RabbitMQ, they actually had to do some steps to get rid of it. That was more complex than it should have been. With the Docker Compose file, it's sometimes very hard to say that what I'm running is this specific version of Clowder and this specific version of the extractors, etc. And really, if I want to restart Clowder, I want to make sure that I have the same version. So I don't want to necessarily use latest, but I want to make sure that I have very specific versions of the extractors and the Clowder, etc. running together. So the other thing is Luigi already hinted at is Clowder. There's a ton of cloud in there. And really what we want to do is we want to move to more cloud-native environments. Very old Dilbert comic where he basically goes through that basically we want to go into cloud-native. And Pointy Hair Boss points out, hey, what about Kubernetes? And that's where we're going next. So this is where we are moving towards ourselves more and more. The advantage is that we leverage not one Docker machine, but we leverage multiple Docker machines together. We basically put them together into a cluster of machines, Kubernetes cluster, that are managed together. And we no longer worry about this one Docker machine, but we can take advantage of all these Docker machines. It is not trivial to set up a Kubernetes cluster. However, if we go to Amazon, Google, Azure, any of those start providing you with a very easy managed instance of Kubernetes. All you do is for Amazon is you ask for an AKS cluster, and that will bring you up a Kubernetes cluster with a certain number of nodes. You no longer have to worry about how do I install the control planes, how do I install the different workers. Basically, you say, I need a cluster with 5 nodes, and that's it. And then a couple of minutes later, and a credit card later, you actually have your Kubernetes cluster up and running. Kubernetes takes care of orchestrating running these containers across the machines. It will make sure that the containers are always running. So if a container crashes, goes down for some reason, a machine goes down, it will migrate all those containers from that one machine to another machine to make sure that they're up and running. You might have a short downtime, but you won't be getting a phone call at 3 a.m. in the morning saying, hey, Clowder is not working. Please, can you come in and fix it? Kubernetes should take care of that automatically. You might get a little blip in your message queue saying, hey, there was a downtime of 5 minutes when the container was migrated. The other thing is that it's very easy to scale up. Extractors, if you know that you're going to have lots of people uploading lots of images, you might say, hey, why don't I preemptively scale up the number of image previewers? That way, we don't run into any issues with any of these previewers being busy. The other thing is that allows you to start upgrading with zero downtime. If we have a new version of Clowder, you can actually bring up the new version of Clowder, and while it's starting to pull down the image and everything else, until the image is ready to go, the old version of Clowder will keep running. And the moment the new version of Clowder is up and running, it will switch over immediately, and you will actually have zero downtime. Now, Kubernetes leverages of YAML files for its distribution. Helm chart is the package manager for Kubernetes. It is adopted by the Cloud Native Computing Foundation as one of its core pieces. And you can use a single command to install. So if you're familiar with Red Hat, you can use a yum install. If you use Ubuntu, it's apt-get. And if you use Helm, it will be Helm install. This will make sure that all the pieces that you want are installed inside your Kubernetes cluster with a single command. Upgrading becomes the same exact command, and I'll show you some examples in a second. There's templates that are a part of the Helm chart that basically create the YAML files that are needed. It will control the HTTP endpoints as needed. It controls how many instances are running, and we can use these to basically easily bring up a complete Kubernetes version of Clowder. The other advantage is that to configure Clowder, you have a single YAML file with all the changes and all the values that you want to save. And so if you put them in Git, and we have an automatic process that basically looks to see any changes and automatically deploys them. Hello GitOps. This is the new buzzword that everybody uses to basically do automatic deployments. We have a Clowder Helm chart. Currently, we are at version 0.12. I'm not quite ready yet to call it 1.0. But as you will see is that the Helm chart has a different version than the Clowder version. It is actually using Clowder 1.17, but the advantage of this is that we can make changes to the Clowder Helm chart, do bug fixes or add new features to it without actually having to rely on the Clowder version being upgraded as well. We can easily add extractors to it, and I'll show you an example of how this is done in a second. And the other thing that it has is, like I said, it's a package manager. It leverages of existing other packages, other Helm charts as well. So we leverage of the Bitnami Mongo chart and the Bitnami RabbitMQ chart so that we don't actually have to reinvent the wheel of how to build those Helm charts. We will leverage of existing Helm charts that are very well managed by a company behind the scenes. So if I look at this, here's an example of some of the changes, and this is the one of the examples of a instance of Clowder that we have running. And what we do is we basically say that, hey, here's the host name that we want you to use. Here's the extra extractor that we want you to deploy. Notice that we basically only need to say that it's the extractor's file digest. Here's the image name, and we want one version of this running. If we set the replica count to 5, we actually have 5 instances run. Here are some extra information that you need to set. Here's the SMTP server. And notice that all we need to do is saying, here's the extra plugins and here's the extra configuration files. These will then get merged into the automatically generated plugins file and the automatically generated configuration file. So for example, if we had RabbitMQ was no longer necessary, because the Helm chart generates the plugin for RabbitMQ automatically, you as a user didn't have to do anything. That plugin was automatically removed when you upgraded to a new version of the Helm chart. We publish these Helm charts to open source.ncsa under the charts, but you can find them at artifacthub.io. This is a great website. This is sort of the Docker hub for Helm charts. You can go here and you can do a search, and if you do a search here at artifacthub.io for Clowder, you will actually find this particular version. You can subscribe to it to see if there's any updates. So you will get an email saying, hey, there's a new version of the Clowder Helm chart. We will also put those updates in the Slack channel under an announce that when we have a new version of the Helm chart with any of the changes that we have. So once we have deployed Clowder, we have them running. So if you look here, this is Clowder running in Kubernetes. As you can see, there's a lot more pieces here, but the advantage is that what we can do now is we have these deployments. You can see them at the bottom, deployment of Clowder, Elasticsearch, and extractors. You can see that we only have one instance of all of those running. You can see that reflected at the top with the Paws. Think of it as a container in Docker that is running. If we would have changed the scale up, saying that we want to have 3 versions of the digest running, you would see 3 of the Paws at the top. The services are the same as that we had for the networking that is done for Docker. Ingress rules are not there. Okay. So, of course, go back to the pros and cons. The same pros as Docker Compose, right? It's easy to update, easy to install, easy to upgrade. The biggest pro compared to Docker Compose is I don't have to worry about, is my container still running? These will get automatically managed by Kubernetes. And if a complete worker node, a complete VM crashes, all the containers that are running on that VM will automatically get restarted on a different worker node. This is an extremely huge benefit for me because now we no longer have to worry how many VMs do we have and what happens if that one VM that we have crashes out? Do we lose our complete stack of Clowder? The disadvantage is Kubernetes is complex. It has a very steep learning curve, but I think this is something that more and more people start getting familiar with, and so I think that con will slowly disappear over time as people get more and more familiar with running Kubernetes. If you think about it, Docker used to be a steep learning curve as well, but over time, more and more people are familiar with it, and people get used to using Docker, and so I think the same is going to happen for Kubernetes. This is currently how we deploy Clowder at NCSA. We still have some of the old legacy all the way to native installs, but as any new version that we deploy, these will be deployed using Kubernetes. It makes it our life a lot easier. So I talked to you about it, saying, oh, here's all the different things. And I told you that we can show you how to start learning how to use this. Katacoda is an interactive learning environment. It is a great resource, and I want to say thank you, Mike Lambert, for pointing this out to me. This is a great learning environment for learning different things. It has a great set of courses about Docker Kubernetes, and we now have a course about learning how to use Clowder. The advantage is that it leverages of pre-configured VMs that are spun up on their behalf, and so you don't have to actually spin up your own version of a VM with Kubernetes or a version with Docker. All that is done for you. Additionally, and I'll show you some of the screenshots, is that we have set up a way for you to slowly, step by step, learn about how to run Clowder in Docker or how to run Clowder in Kubernetes. So if you go to that URL, you will see this. You will see the Clowder. There's 2 scenarios there, and I hope that we can add more and more scenarios there as well as some container basics and Kubernetes fundamentals that I think are very useful courses for you to learn more about Docker as well as about Kubernetes. So if you're not familiar with Docker and Kubernetes, I highly recommend going through those 2 first before you jump into the Clowder course. So the Katacoda Clowder Docker, it will teach you how to use Docker Compose to bring up Clowder. It will show you some of the configuration files, start Clowder, initialize a user, and browse to Clowder. These are basically the basic steps that you should use to get Clowder up and running. The best part about Katacoda for me is that once you have it running, once you start with this course and you have it up and running, you can go back, change some of the configuration files, do Docker Compose up again, and see immediately the results without having to do all of this on your own machine. So what does it look like? Here's, for instance, the example for Clowder Docker. You start off with looking at the Docker Compose file and the ability to look at the Docker override file. As you see, there's these dark gray bars. If you click on those, it will actually execute the command in the Unix shell next to it. But you can actually do any simple Unix commands that you want. It's a complete Ubuntu VM with Docker installed for you. But as you go through the course, it will show you what to do. It will tell you what to look at, and will actually have commands that you can execute. So for instance, in this particular case, I clicked on the make clear command, and you can see that those commands were executed and sitting there in the command shell. This is one of the commands that we often tell people to do if you want to use Docker and want to store the data inside or on your VM, but not inside the Docker containers. These are the commands you need to do. This is what you need to look at in the Docker Compose override. And this course will actually show you what to do and how to do this. Once we've done that, it shows you the commands to do the Docker Compose up, and then to see that Docker is actually, the Clowder is actually running. So if you look at the bottom and the right shell, and the shell, you can see that Clowder is completely up and running. And then finally it says, hey, connect to this particular host name port to see Clowder running. We first add a user because Clowder doesn't have by default any user, so it shows you the command to actually run to add the user, and it shows you the output that you see in the Unix shell. At that point, you've created a user, you have Clowder up and running in Docker, then you can actually connect to Clowder. So if you look at it, once you click on the link, it actually shows you the normal Clowder interface. This is a version of Clowder that is running in Docker, that you set up, that you can control with, that you can play with, and stays up for a couple of minutes, I don't know exactly how long, while the session is still alive. So as long as you are playing with Catacoda and you go back and forth, like say, oh, I want to see what happens if I add another user to it. So, wrong way. What happens if I want to add another user? You go back to your shell, add the commands to add another user, and you can basically see what happens. If I run the same command, what happens? If I add some, make some changes to the Docker Compose override and do Docker Compose up, what happens? And you can play with this as much as you want without having to worry that you mess up or do anything bad to your laptop or to the production environment. We have a second course, which is Clowder Kubernetes. This will actually teach you how to run Clowder in Kubernetes. It will basically go through almost the same steps that we did with Docker, but it will use Kubernetes in this particular case. So it will make sure that you have a Kubernetes cluster up and running that has all the pieces up and running. In this particular case, if you look at, hopefully you can see it, if you look at the screen, you can see that we have one master node and no worker nodes. I'm not quite sure yet how or why, but sometimes you end up with one master node and no worker nodes, and sometimes you end up with a master node and a worker node. The other thing is Catacoda, and I described that in the text itself, does not have a way of storing data, and you'd actually need to create a persistent volume. This is something you should become familiar with if you take the Catacoda courses about Kubernetes, to store the data. Once you have that running, it shows you how to do import the Helm repo for Clowder, and how do you find the Clowder, the configuration file that we discussed earlier, and that is preloaded on your machine already. In this particular case, you will see that it has pre-configured a user in there, so we no longer need to run the Docker Compose or the Docker init command. That is part of the Helm chart itself. Once we do a Helm install Clowder, it will go through and will basically install Clowder as a Helm as Docker files. This will take about 5 minutes to pull all the images down and get all the pieces up and running. Once we have all that running, since we don't have an ingress port, I need to do port forwarding to connect to it. But at that point, I have a complete system up and running, and as before, I can connect to it and look at it, log in, and work with it. Again, if I wanted to, I can go back make changes to the values file, do a Helm upgrade, and see what happens to it. So this, again, is a great way for you to experiment with it, look and see what are the changes I can do, what is the impact if I make any changes, how does that change, what's the right syntax for things. And it's a very great playground for you to learn and play with the Clowder Helm chart and learn how to use it. So that is my presentation. And so if people have questions. And like I said, the Katacoda course is available. If you go to katacoda.com/Clowder, you should be able to play with it yourself. It's all an experiment.
Thank you, Rob. That was great. Yeah, I definitely look forward to getting feedback from people going through the Katacoda course.